Can you hear now? Yeah, that should be. Okay, so this is basically what we try to do. And then if we try to reach net zero carbon emission by 2050. So what is our current status? What is the pathway move forward? And how can we reach that? Okay. Yes, that is even people, okay, have a lot of debate about whether that climate change is real or not. But from the recent evidence, it looks like we don't have choice. We have to basically set the goal and then carry it out. Okay, and then the other mission that on this workshop, what we try to do is the measurement. Okay, so how can we, because the climate change, it doesn't happen. Okay, Bill is on the semiconductor industry. They're looking at the gigahertz. Okay, from the climate change point of view, yes, our data, yes, one season, 1 year, annual event. So it doesn't happen second by second or year by year. So it's a long term, and it's a lengthy process. And Bob mentioned, okay, well, even the permafrost, the several cold season is going to bring it back. Is that right? So when you look at it, what is the trend? And then measurement is one thing. How can you turn the data into the information? And from the information into the action item.
So maybe we could ask people what
they want. Then what basically, yes, that is the, now I will stop it here and then ask your input now.
So we put the 4 points down, right? Looking at the low carbon energy production, it does not necessarily have to be remote locations, but that was one of the focus areas. Can be anywhere. But looking in particular with under the conditions of cold climate and so on. And if you go further, so often when we do this type of workshop, we look at it and say, okay, what are the possibilities in terms of technology? What do you define as the gap on the technology side, but also in terms of deployment, what are the barriers, and so on. And are there any transition plans? Can we help with a transition plan? Or do we need to build a full-fledged roadmap? So that is the question to you as a group to see where we can continue this work. So based on our discussion, we want to figure out how we can continue this work to make a contribution, if that is possible and if that is of any value to you. We did write down a few points on the next slide, but it's just called ideas, right? Just to start, that's all. So with that, we do have a few folks online. So if you would like to speak up, please raise your hand and Iptica will let us know. And then we'll invite you to contribute. Thank you. With that, so who would like to make a statement, a question? I also understand, Jennifer, you had another contribution you wanted to raise. Maybe we should do that first before we forget that.
I have a link that I can share with anyone who's interested. We can also put it in the chat that describes Kotzebue's system and some of the things that keep it operating. Again, I can share that, here, and we'll put it in the chat. And then I also have an email address where you can email the gentleman who operates the utility there. He okayed for me to share his email address, and you can ask him some specific questions if you have them about their system and how it's operating. But he did confirm for me by text message what was mentioned earlier, that they have production coming out of the back of their panels, and angle of incidence is a production factor for them, and that this is their big production time of year until a few more weeks from now, but they're in their big part of the season right now.
Do they still have snow on the ground?
Yes.
Yeah, so that's how the back of the panel is functioned. So they're essentially getting double. Well, not double, but quite a bit extra. Yeah.
I want to respond to what Eugene was talking about. Yeah.
Okay.
I think the idea is to evaluate the data that we've got and try to come up with what the real problem is or real problems we have where the data may have been misleading people on what we're looking at. So I think that's one of the things we have to look at is identify what the real problem is in the location you're at or in the art it is. But, you know, just melting permafrost is not the problem. There are other things we have to look at to find out what it is. So I think that's key is look at what we've got and find out where we need to be looking next. And I know that
So
Amy's got things that she'll look at differently for some locations and all that. So, but it's understanding what the data is telling us and then move in the right direction.
And then also try to look at it, okay, you have a problem, and then you are also looking for the accountability.
So let's try one other thing before we go to you, just a sec. So if, like, we've been talking data, and so maybe let's talk data for a moment. So if you had your druthers, like, could have what you like, what is missing? What is not measured? Like, I heard access was one issue that, utilities are, that was probably in the breakout session earlier, that utilities don't share data, so people don't have access. But if you are looking at the whole data, climate change monitoring, ecosystem monitoring, whatever, what is it that you're missing in terms of data? Or do you have everything you need to make the decisions you want? Like, dollar is not a question right now. What is it you would measure if you could? Yes.
And back to Bob's presentation, probably do more careful, more consistent, more systemic measurements of the active layers and temperatures of permafrost and keep the probes there year round as long as we can and maintain them almost like weather stations, just so we can keep a good eye on what's actually going on. That would be near the top of the list of things that I think we ought to be measuring.
So what you're saying is extensive active layer monitoring down to the permafrost layer. Okay. Well into it. Okay. So you're looking like 10, 12 meters, 14 meters, 15 meters. Okay. So yeah, well, it's good. So 30 or 50 meters. So that's one. So this is the active layer piece. What about the people talking about the firewall? What is it that you are missing in terms of measuring?
What we're missing in terms of measurement, well, first of all, firewall is a highly interdisciplinary project, and we have natural scientists as part of the team. We also have engineers, also social scientists, and each group is working on their own respective area, and the nature of data in each domain is different. And I would say what we're missing is a good understanding of how these data layers will come together and how we could gain insight from multiple layers. So that convergence is something that we want to know how we can even do.
All right.
So that's what I would
So-
say. Data are there, but we need to know how things come together.
So with my understanding from the Firewall project is that you do some very interesting ecosystem monitoring in terms of tree health and all the rest of it as well, right?
We won't do that necessarily. I mean, we're not collecting all the data. At least our team is not doing that. Because lots of data are out there. So we are relying on some of the research that has been done before us.
Okay.
So we're not the first group who is doing
Okay.
wildfire research. As I said, better understanding, how things come together. So there might be some research already done that can benefit our wildfire research. So we just need to learn how and how to connect all these layers together.
So, yes,
Sure.
But first we have to know what we want to do and what we're looking for. So are we looking, what is the objective that we're trying to meet? Second, we need to have a model, a conception of how the parameters, the parameters are related and how they fit into that model. And that model is to reach a certain objective, whether it's to know how much the temperature is changing, whatever the objective is. So you need having sort of a model, doesn't have to be perfect, because many of these problems do not take an exact simple model. Then you identify what are the main parameters that will affect your model. In some of them, the parameters of the model are more sensitive than other parameters towards the objective that you're looking for. At that moment, you have identified what you want to measure. So it's not just measuring everything around us, it's measuring for a purpose. So that's how we look at that, and we're working in a number of projects related to this concept, like wildfire propagation and response. We're also working on earthquake early warning. We need a model behind in order to know what parameters to have.
so I fully agree. I had asked the question, assuming that everybody here actually has a project that they're working on, and hence has a need. So hence the question straight for what do we need to measure? But that was the idea. So Jen, go ahead.
Yeah, so I like what you were saying about the models, and for us, one way that we do modeling is with the Homer software, trying to basically do an economic optimization based on fuel curves and trying to size systems to get the most economically efficient microgrid. So there's software that does that, but there's two problems with it. One, it doesn't necessarily have all of the options in it to align with how the grids are actually operated. For example, the graph that I showed of Shungnak, typically the PV, when the sun is coming up during the day, all of that energy is going into the batteries to charge up the batteries before it is being used to offset load necessarily. So, if you have, you have renewable, you have energy, how are you, your energy orchestra, how are you going to conduct it, right? So, the models don't necessarily allow much flexibility on that. The second is that there's not a lot of model verification, being able to take the data and plug it back into the model later and see how right you were or not. Like we just make models and guess and fund projects someone, and there's no closed loop on that. And so those are my two complaints about models and data.
So you would like a model that can learn.
Yeah.
Yeah.
Yes.
Sounds good. Thank you for that
Oh,
contribution.
wait, sorry.
Model has to be interactive. Has to be that if you collect certain parameters and put them in the model, you have to see what results now you get from the model, and the results will inform what next more information you need.
Mhm.
Our next parameter to emphasize. So it has to be a closed loop.
Yes, absolutely. And then one more comment. I think we shouldn't neglect the social data either. Like what Michelle has done with the EVs or what Jennifer is doing. You know, we can play with numbers all day, which is great. That's what we all love. But then is it going to actually get used? I don't know.
Sure, yeah.
So just a kind of a fun thing we were doing here. So I have a PV system with batteries, and as a homeowner, I set the preference of how I want that system to operate when it goes online when the sun comes up, and I do exactly what you said. I charge my batteries first, I run the house, and then anything left over I export to the grid. So in this time of year, it takes about 2.5 hours before the batteries charge when the sun comes up. And then the rest of the day it's running the house and exporting to the grid. But I did this little other exercise. There's a site that NREL has called Paul Victor PV Watts, which is pretty accurate. So when I built my system, I used it to determine what size array should I get. And it was dead nuts every month of the year from January through December, within a couple of hundred watts, depending on the, on the weather patterns that we had. And I just did it just for fun for here. So I just put an array in there of 1 kilowatt DC. And it turns out it was kind of interesting. I just used an arbitrary address in Anchorage, which I don't know, but I just picked one. And it said on their house, for a 1 kilowatt array, it would generate 1 megawatt hour. So then I put in my address just to see what a 1 kilowatt array would generate. It would generate 1.3 megawatt hours. So that would mean if you wanted the same kind of capacity that I have, you'd have to put in 30% more array size. So it's a big cost difference. And then just for fun, I put an address in San Jose, and they got 1.7 megawatt hours. And then I put an address, I put my sister-in-law's address in Arizona, and they would generate 1.8 megawatt hours. So, there is location makes a difference. And I think Ken did the same thing, and he got 0.9 megawatt hours per year instead of the 1. So different address, different weather conditions, different sun activity during the day. So, I would say that solar here is more costly. That's my opinion. I sized the array at my house so that I had 2.5 times excess capacity, because in the wintertime, I would not, if I put in exactly what the manufacturer recommended to basically maintain roughly a 20 kilowatt hour per day, or 20 kilowatt hour per day average, which is about what my house uses, I would not be able to be net negative on the net metering throughout the year. So I put in an array that was bigger. So on peak days, I generate 80 kilowatt hours. And during the winter, it goes way down. And I generate typically on the average of 14 to 18 kilowatt hours. So I'm close to the 20 in the winter. So I sized it, for the worst case conditions where I live. So I'm just trying to give you some rules of thumb, and use that site. So it's a pretty good site. It was very accurate in my case in my house. It's probably okay here too.
When we talk about, I don't think, okay. When we talk about feeding, it helps. Whether or not it's more costly than what? Solar is more costly than $9.50 a gallon diesel and having to buy 2 million gallons of it to get through the year. I don't know, every single year, and being then tied to the boom and bust cycles of diesel costs. So when you talk about comparisons of like what's like something being more costly, you have to take into account the alternatives that are available to most of the people here. So I would think that it makes a little bit more sense to focus on something that, in terms of policy and what's popularly discussed, we're talking about solar and we're talking about wind. To me, the focus needs to be on efficiency. When you talk about housing and some of the technologies available to just live a simple, decent life and be able to run a computer in your home and all those kinds of things, what people in the Arctic in particular really want us to focus on are things that for which money is isn't really available anymore. Our policy is pushing us towards technologies and experimentation with technologies that, yes, solar is proven, wind is proven, but here in Alaska, until we have that ready for scale that we know, is ready to roll for everybody, the most equitable thing to do is to focus on energy efficiency in our homes and in our operations in a lot of other ways. I just, I understand that everybody has a different perspective, but that's just mine from going out and visiting folks all over the state and knowing the issues that people are having getting funded to explore these efficiency questions.
And that's all energy use, not just electricity.
Probably not practical to install that kind of a system on your house because you just don't have the roof space. I mean, I'm using most of my roof space to do the system that I have, and yours would have to be 30% bigger. And your average load probably is more than 20 kilowatt hours a day here. I don't know. That's what mine is throughout the year. So, air conditioning and heating, it's on, I smooth it out. It's about 20 kilowatt hours a day. But the thing that you have in Alaska that I don't have is you have land. So I wouldn't recommend putting systems on roofs here. It's probably kind of a dumb idea anyway with the snow load that's up there. I would put them on land because you got plenty of land, and that's where the political piece comes in, because you would want community solar in this particular case. That would be the way that I would push this. I would not push individuals to start energizing their homes with solar. I would look for community solar because you have so much land. So why not use it?
I think we've had 2 people speak to the conditions of the land here and the difficulties involved in that. I can only, I think, best speak to the governance systems that make that a much more complicated idea than it seems. It's really hard sometimes to determine ownership here of land, and even where it is determined, there are public and private bodies with layers of rights on top of that land. The Alaska Native corporations, tribes, and then boroughs and state government and all that. It's a really complicated land governance and ownership system here. I would also offer that in many cases, it looks like there's a lot of land available when there's actually not. Between the cultural resources management questions involved and the soils issues involved, logistically, I really wish, if you wanted to come up with a model for something, that somebody would take each town and say, like, this is the amount of land that you actually have available to develop for a utility scale renewable project versus what it looks like you have. That would be super useful.
Can I ask you a question? In Europe, and we were trying it in Canada, but didn't really come off. But we've been looking at community-owned installations. So, in other words, people get together, they buy shares in a new community-type corporation that runs essentially power generation, either with wind turbines or with solar installation or whatever. So it essentially keeps the quote unquote profit from the installation in the community as opposed to with the large corporation. So it's like a co-op, right? So it's the old co-op idea. And I wonder, is that happening at all in Alaska? You are, right?
There's legislation.
I think one of them, I think what she's doing is all co-op. I'm pretty sure. Yeah.
Well, there's the community energy or like community solar project concept that I'm familiar with from Michigan, for instance, would operate a little differently here because of the legal structures that we have in place. But I think essentially it would be very similar to the way that villages operate right now, especially if it's a tribally owned utility. So we already have community energy. So the question really is about technologies and affordability and the balance. It's, we already have community energy, I think.
Well, so two things. One, if us as a utility is going to allow an entity to become an independent power producer on a village system, we're not just going to let anybody do that. The community wants that money, that economy, to stay within the community. And so this independent power producer is pretty much exclusively going to be a tribe or somebody that some way to keep that within the community, keep it local and keep those benefits local. Another thing to keep in mind is it really is how big is the system. I would say a good rule of thumb, which you have to be careful with rules of thumb, right? But I think about 5% is about how much residential renewables is before we start capping, essentially. And there are communities where, you know, we can't just have everybody putting rooftop solar on their houses. That, you know, if the clouds come by, the whole system's going to go berserk. And so, you know, we actually have to put caps on how much of that we can do within a system. 5% is a good rule. But at that point, because of the scale, you do have to start migrating to community or utility scale renewables. Of course, I'm going to vote for utility. Even with community scale, you know, the systems are so small that there has to be a very tight level of collaboration for the controls to keep everything stable and working.
That matters. So a big factor, and this is actually true in Sweden as well, if I understand correctly, you have a program that understands that in the Arctic, that affordability is an issue for people, and so they have a power cost equalization program. We have that here as well. We call it power cost equalization. And basically what it does is even out the energy costs for people who live in rural areas and would have much higher bills, even higher than they already are. Now, that would be a factor in affordability in terms of deciding if you want to go to community energy or not. We're already doing community energy. We just call it something different. We've tribally owned utilities. And that's just the way that a lot of places are operating anyway.
So this does come up with, especially with heat. So now we're going into, well, we want to install an electric boiler, or other communities have looked at dispatchable heat loads in residential. And there's a couple communities that do that actually pretty successfully, but they do it in kind of an interesting way, and I won't go into that. But then the question is, well, how do you do your metering for these electric heat loads? You know, power cost equalization doesn't really account for any of that. And so, you know, how do we, if we're moving towards renewable heat loads with electrification, how can we do it in a way that we aren't going to shoot ourselves in the foot when it comes to that program? And because, yeah, well, I don't know if that answers your question or not, but
You talk, right? We'll try to figure it out. Rakesh, it's your turn.
So I told you I was gonna put on my data hat, right? So you're generating a lot of data. You're using a lot of data that's available. The platform that we have is very flexible. We're scaling it up. We want to put in what I call solution zones. So you can envision, I don't know, an Alaska zone or an Arctic zone, whatever. But the kind of thing that you could do is, if there's a set of data that you want to analyze, you can model it yourself, or you can create a design competition where you can draw in researchers from around the world to help solve the problem. and create a model that would be next gen, if you will, right? I'll give you an example. There's data that's being generated in Bangalore for traffic data, and they're collaborating with us. We're going to open that up to worldwide global researchers to develop predictive models. So keep that in mind, because I think there's a lot of powerful information you have already, and then you could generate with the use of that platform. And by the way, also there's a new publication that IEEE has. It's called Data Descriptors. You can write a little 4-page article, very different than current articles, but it describes your data set that then becomes public information, and it's easily findable. So a lot of value in there. So I make a pitch for that. I think that you have a lot of information that you could share and benefit from. So that was my data port pitch.
There was a pitch. Okay. So we had a long list of potential energy generation in different places. One of the topics that I thought we didn't talk about a lot is, but we did a bit, is the ocean, like this fantastically long coastline. And I think maybe in a follow-up, we want to do an online event, maybe one of these days, where we bring the ocean community together with you. And for two reasons. One, measurement, because as my colleague Christopher Witt says, you know, looking at the ocean is like taking this telescope and getting this tiny minuscule piece of information, which is much less than what we know about the surface of Mars. Because of course, looking into the ocean is rather difficult to get information and so on. So that is one topic that the ocean community is interested in. They're also very interested in, number two, to see whether the ocean can handle carbon sequestration, so marine carbon removal. And the third topic that, and you have referred to it, is that the ocean also is a big, huge battery. In other words, there's an awful lot of energy stored in the ocean. So are there ways to very benignly harvest energy from the ocean, like a tidal project? Or maybe there are other ways of doing that. So there's exploration going on in that area. So I'm wondering whether you might be interested in like an online event at some point to actually figure out what might be of interest in terms of the proximity to the ocean on this very long Alaskan coast, of course, with ice. Okay. Any thoughts on that?
General comment about taking advantage of the ocean. There are two mechanisms. One is tidal and the other is wave. So both can.
It's up and down.
And the tidal is up and down. The waves is just a regular turbine that intercepts the waves as they naturally go. And there is a project in British Columbia dealing with those two sources. That's all what I know.
Yeah, there's one out of UBC, I believe. Okay. Okay, any last comments in this session about energy?
I don't know if we discussed.
Pardon?
I do not know if we touch on or we're going to touch on later on the consequences for people and communities of deploying one type of energy or another.
Okay. So we were touching on that to a certain extent yesterday. Okay. Yeah. So the about saving around maybe only half of it, 5% of your electricity bill. Not so, and it gives ownership to people to essentially conserve energy. It comes from one of our friends in Vancouver, actually.
The other aspect is hot water. So hot water represents an important part of the consumption, especially in everywhere actually. So when do you heat up your water tank? You should heat it up when the demand is the lowest. So you have the least impact on the capacity of your assets. So sharing a water tank in a community is something that is in new developments in Germany right now is taken in consideration. So they have a centralized water tank that is shared by a number of house units, and it's a common water tank. And the water is heated 3 in the morning when the electricity demand is the lowest.
Pardon? Yeah. It's different. Like we really have to look at how housing is done in different communities, whether any of these pieces work or don't work. Right. So anyway, with your permission, I'd like to stop this discussion here. I think Susan has the report out from online from our breakout session that we had online this morning. And I think Wei Jin will report on your breakout session that I know nothing about from this morning. So, and we'll try to be finished by 5 o'clock on the money. How's that? Anybody wants to get up and get another cup of coffee while we get Susan on?
Yeah, if you would like to fill out a hard copy of your professional development hours certificate survey. I have some here. It's easier than having to do it online and then emailing back to me because you've done with the stats.
Do the 2 people who were on all day yesterday and today online qualify as well?
Well, if we were here today as well.
Yeah.
If
So
online, if anyone was here for 2 days.
We can see that. So
Yeah, they can certainly submit their certificate, but they have to do it online.
Yeah, basically her, yeah.
I am from Tijuana. Oh, thank you very much.
Can we hear Susan? Are you there?
Oh, yeah, I'm here. I'm ready to share my screen.
Yeah.
If somebody, you have to stop sharing yours first, though. Okay, looks like it. Let me try. Okay. Let's see if I can do this. There we go. Does that look okay? Okay, should I share my screen now? Can you hear me?
Yep, no, we can.
Okay. All right, there are people back from their coffee? I didn't hear that, Mikey.
Well, you can start talking.
Are you ready? Okay. All right. That's what I was checking. We were people from Canada and California. So we're like those people that Jennifer mentioned, who you should be aware that you're wearing the outsider's uniform, right? But we were talking about, what we've been listening to earlier in the morning, and considering the points that Mikey had raised about whether, for climate change mitigation and climate change adaptation and resilience, what did we think was the most important? For climate change mitigation, we felt that the Arctic use of energy was really not large enough to be relevant to global climate change mitigation. The change there should be done for the kind of future proofing that was talked about in some of the talks from local people, and for having climate resilience and energy efficiency and avoid harming locals from pollution, and all those things are good reasons to use non-renewables in the Arctic, but not really climate change mitigation was what we thought. Then we thought that retraining the workforce was essential to transforming the energy system. And Professor Kinsner has a lot of interesting ideas for using digital twins in training that we talked about for a while, and that would be like a whole nother section. And also just about the use of digital twins for duplicating parts of power systems. So Mark from Mikey, what's the name of his organization? Do you remember? NRCAN, I forget what that comes out to. But anyway, he works with the northern parts of Canada, which are in some ways similar and in some ways different from the situation in Alaska. The main thing being that there's very little. The Alaska has more of a association with the oil and gas industry, and in Canada that's more like Alberta, right? So anyway, I don't want to go too much in that. I just want to go through the key points. Mark and Whittle both had a lot to say about how the data about power systems needs to be shared in order to go forward and abstracted into models. Amy, I think, was talking some about that today too, how she needs a much better model of what's going in there. That advanced technology systems in the Arctic and more data gathering, which Whithold is very interested in from satellite data especially, can be difficult to fund. And the key point in relation to both data sharing and funding is that research, government, and industry need to work together with stakeholders on the ground, the public, with a transdisciplinary approach, especially. I want to say, is Jennifer still there? I wanted to say how much I enjoyed your talk. I would like to invite you to at least come by sometime to IEEE 7800 and talk to us about community agency, which is part of what we're looking at as in the professional practice of engineers. Thank you, if you're there. And I think that is really what I have to say. Mikey or Whittle may have something I want to add. Well, I can't hear any of it. You there? Okay. All right, I'll stop sharing now.
Okay.
Unless Mikey or Whittle wants to add more. Mark had to leave. He's in Montreal, different time zone, far away. So.
You told him left as well, Junior, to send some hello. Hello.
Uh-oh, that's the bad mic, Mikey. I can't hear you. let me get off and reorganize.
Can you hear me now?
Oh yeah, that's better now.
Now?
Still a little garbled. Yeah.
Can you hear her now?
Hello.
Hello. Yes.
Okay. So
Okay.
sends her hello. I sent you the connection information, so we can go from there. So there was a couple that I thought I should mention that were also brought up this morning, and that was the de-fingerprinting of data.
Yes.
As it was said that agencies, groups don't like to share data because they don't want to share vulnerabilities. So if we can de-fingerprint the data and so that it cannot be traced back to the source, but it can be identified with circumstances that maybe exist in 20, 30, 100 other locations around the globe, then we can use that data to do research and to carry on and carry out work. So de-fingerprinting of data to make it available was one of the big pieces that we wanted to bring forward. And so essentially system security by obscurity would not work. What we have to do is make our systems fail safe. So that was a little message at the end here. And with that, maybe you can talk about what was discussed this morning in this room.
Yeah, this morning, our discussing focus on the mitigation and adaptation side. And so we kind of extended yesterday's idea on the toolbox point of view. For example, on the mitigation, especially on the energy production side, we talk about the run-of-river, hydro, tidal, SMR, geothermal, wind, solar, and the biomass. So on this way here, different technology has a different pros and cons. And the different location, they are location dependent. So yes, the presenter today that they talk about some difficulty they have encountered. And then on those, basically, yeah, we understand in Alaska or in the Arctic region, then we have to face a relatively harsh environment and some situation that not commonly thought in the lower 48 state. So in other words, then we identify the problem. Then we also like to everybody give them input on how to solve those problems. So on that way, we basically identify the potential technology and identify the challenges, and then how to create a roadmap or find the solutions. On the adaptation side, we also identify several impacts from the climate change. Okay, so from the permanent forest variation, the activity, and also the erosion on the coastal area, and also the ice melting situation, or another the basically impact on the geoeconomic system, the ecosystem. Then how can basically on this way here, we understand we are not going to go back to the original point. So how can we adapt or hardening our system to basically make the situation overcomable and manageable? So this is basically this morning that we look at it. Okay, so we try to summarize it, and because we understand a lot of technology that sometimes it sounds very good or it's very promising for a point of time, and then in the long run they may disappear. Okay, so we also like to look at it, what will be the prospective outcome on those technologies. If we try to look at it, say, okay, in 2050, we are going to reach the net zero carbon emission, okay, for the community. And yes, I understand it's a difficult task. However, that we need basically from the group discussion point of view, we like everybody's input because this is a collective effort and different location, different region has a different constraint. So this is basically the summary of our morning's discussion. And anybody want to add on or have any other suggestion or comment?
Actually, I was to add a couple of things. When Susan talked about, we didn't look at things necessarily from a climate change point of view. This was a comment from our colleagues from NRCan, Natural Resources Canada, who work with northern communities and in Canada for power and water, et cetera, like it's a integrated approach. So their comment, in particular Mark's comment, was that people would not necessarily in northern communities be interested in climate change, but they're definitely interested in being able to turn off the diesel generator and not having to suffer through the noise and so on. So in other words, other reasons for using different technology, not being dependent on diesel, not having the fumes, the noise, having a more cost-effective solution potentially, and so on. So that was that comment that climate change was not necessarily the driver for change or was that much of interest to the communities, but of course, reliant, resilient energy systems, water systems, healthcare, education, workforce, and so on. That was the driver for doing things differently and better. So I think that clarifies that statement at the front end a little bit. Okay, so and I really like the idea of de-fingerprinting the data. Like we've talked about it a lot. There was the other question was raised again in that discussion as well about the data governance, data ownership by the indigenous communities. So we can share with you from the Canadian side what is being done there. So maybe that's of interest to some of your colleagues to share, because I think some of those concerns are very similar, right? So like that border that goes across the north, it's pretty artificial. Somebody put a ruler there, right? So the ice doesn't care, the snow doesn't care, the wind doesn't care, and a lot of people don't particularly care either. They just put up with the nuisance of crossing borders. So anyway, that was that. Any final comments from any one of you?
I was wondering what the consensus might be here. I don't think diesel and natural gas are going away. I think the use could be going down and alternative energy is coming up. Is that kind of where we end up with, or?
I thought the presentation that we heard from Charlie Vartanian about the installation of batteries in conjunction with diesel and so on, and reducing the total diesel use was rather interesting, because the installation, or like getting ready with the installation with the battery and putting also allows the integration of renewables, and so slowly you could move from one system to the other. And I thought that was an interesting transition strategy. like an actual strategy to be able to have both and move forward that way.
Usually speak up my mind, so forgive me if it doesn't make sense what they say, but no, no, no. What's the big fuss about this? And don't fall all on top of me now. I totally understand, and climate change is happening, and all of that is happening. But if you can reduce the use of diesel from 100 to 10, that would be a good thing, right? Yes. So my question is, if you adopt mostly wind and solar for most of your, to cover your load, you will still have gaps. What if you use diesel to fill in the gaps? That's not a big deal. You'll end up with maximum 10% or less than 10% of diesel use in a year. So compare that with the cost of installing batteries to store the energy at a very high price. Oh, you do? I mean, you. Okay.
So suggesting whether we could have a system that would have diesel and renewable, but no battery.
Because the batteries are more expensive.
We've been doing.
Yeah, that's what they've been doing.
Perfect.
Yeah. So, but that limits the renewables to a certain percentage. And if you put the battery in, then you can put more renewables.
But then you minimize the amount of battery you need. So
Always.
diesel helping.
Yeah.
Even out the
Mohammed?
We've been hearing a lot about sharing data and sure, and how that can help with research. That's true. I agree. But we should also see things from the perspective of communities, right? Why should they share the data with us as researchers? A lot of, I've been hearing a lot about lots of research. A lot of researchers go to communities. They ask for data. Sometimes they get the data. They do maybe 2 years of research, and then they publish their paper and they disappear. Yes. So my question is how that mechanism can change. So what can we do as researchers, or what IEEE can do to change that?
So the original comment that I just made with the defingerprinting was more meant for like utilities that don't want to show their vulnerabilities. But that's okay, but it's another problem. Yeah.
And I think you're referring to research data, for instance. Like if you publish in Nature, you have to submit that, or your article doesn't get published. Yeah. Oh, because by definition, if it's research, the data is available publicly. It's not private. It's not protected. Again, get into deeper.
So what you're getting at here is actually a rather deep-seated problem, because as a university, you want to graduate your master's and your PhD students. So they need to do these studies. And the goal of the university is to turn out these students, and they are becoming highly qualified personnel and they get jobs, etc. But the goal is not to help the community. The goal is not to help, say if you have an industrial partner to work with, like that relationship is usually finished with the project. And that is why a lot of the work that we actually do in our schools does not actually get translated into actually being used because it ends with a degree. That's a problem that's true all across North America. That, yet it is a real problem.
Yeah, it's been my, I guess, dream or vision or whatever it is, that the interactive work between ASAP and the villages and stuff, that whatever would get published out of that might be typical design of that type of system. I know a lot of people look at their stuff as proprietary and they don't want to share it because I'll get the next job, but I know that a number of companies have their own microgrid controller. Schweitzer's got one, ABB's got one, but I've been hoping all along that somewhere out of the effort that's been, that there would be typical solutions for wind, diesel, battery, whatever types of systems of this size and that size and other things, so that some new community coming along saying, okay, we want to do that too. We want to be just like Kotzebue or Sugnac or whatever it is. So, and that, I don't know how we get past the proprietary part of that, but since a lot of it's shared information with ASAP and other things, that it's kind of public or whatever it is. I don't know if Amy was going to share any of her solutions with others, but that's a thing I've been waiting for probably the last 15 years, is people producing, here's how we can do this in a real community that looks like this and that size, with here's the manufactured product we use, here's how we wired them together, here's a drawing and all that, just so the next community's got something to start with, so their learning curve is reduced, so they don't have to expend quite as much to get started. But that's the way I thought the data would be shared a lot, is share the practice.
I was at a meeting the other day of, again, engineers, the only person, not an engineer, but we were talking about workforce development, and the meeting started as women in STEM. And by the end of the meeting, it was first generation college students in STEM. The idea being that to broaden the pool of people entering the engineering as a discipline, in entering the field as practitioners, that sort of thing, researchers, whatever, you needed to capture the imagination of people who did not come from engineering families, because they did an internal survey, and UAF and UAA were talking, and they just basically found that most of the women in their programs actually came from engineering families. So if they wanted more engineers, maybe just look at even before high school, like elementary school level programs, to capture the imagination of kids who aren't from families, maybe they're first generation college students, or they're from families where, you know, one's a teacher and one's a police officer, for instance. So I think that that's a little bit of the answer to your question, is that as if we broaden the pool of engineers who work on these problems and are from the communities that you're researching, then there's a certain aspect of utility to the research they're going to do. So there's a little bit of a workforce component there that can answer some of your question. The other thing that came up was the idea that researchers of color in the engineering discipline are over-mentored and under-resourced. And what they meant by that is that there is an understanding that mentorship through a career is very valuable. And then once you broaden the pool of folks who are engineers, then you want to provide that disciplinary mentorship throughout their career. Okay, that's great. the people need to get paid, right? If they're a researcher, they need to get the grant. And what they found is that the pay is not coming along with those mentored people. And so there's maybe a certain amount of like instilling, like going out and making money, and maybe not waiting so much on permission from your elders to say that you're ready. And I think there's a little bit of truth in that when it comes to doing research in the communities, at least here in Alaska. The idea, no, you're not ready for a project yet. You have to do your research first. Engage with a planner, talk to UAA and get an engineer and come and talk to you, rather than saying like, let's figure this out and get a shovel in the ground. So there's a, you know, the communities are in a like an analogous situation to some of the engineers there. Yep. And the third thing that I would say about that doesn't come from that conversation is the idea that it's about billable hours for engineers. If you're in a firm, it's about billable hours. You don't get rewarded for that relationship building in the community, because how are you going to cover those hours? And it takes a lot of time. It takes travel, especially out here, order of days, staying in places, sleeping on high school floors, staying at National Guard armories, and engineers, especially in firms, don't get compensated for that. And so, you know, there's something about your discipline that you can affect in the firms where you work, and you know, same thing with researchers. You know, we're rewarded by churning out papers. You know, if we had a reward system that included community engagement over your research and gave you travel money for that, then that might get at the answer to your question too, right?
And possibly maybe a naive comment, but I think it goes along with what you just said. If there was some source of funding for research, that when the research is using data from communities, then that research can become a pilot project for that particular community. So it goes full circle, and you know, the research data is used with the community and nothing gets lost.
So the research is only one step on the way. Yes. Yeah.
So,
good idea.
I mean, I will give you my practical opinion. So what I learned here throughout the last couple of days is there is no single solution. You know, we talked about solar and renewables a little bit. We talked about diesel. We talked about small modular reactors. We talked about the fact that here everything is pretty much islanded because each area has their own microgrid. I think what I would like to see, if this group is amenable to it, is that you write a white paper and describe all of these options, and then create a challenge, and let the community respond to the challenge. That IEEE is great at competitions. We use Dataport to house the data. We use IEEE's backbone to run the competition, and we ask, you know, do you have any innovative solutions? And let's see what folks do. They don't have to be in college. They could be high school kids. They could even be elementary school kids. We don't really care. But maybe we should do a challenge and a competition, which we do really well at IEEE. That's one of the things we do really well. When we say, hey, we got a competition, you know, and even if the prize is just recognition, it's a really important thing for whoever wins those things, and we decide to do something with it. And it helps those folks with their career. So that's where I'm coming from. I mean, we talked about a lot of different things, and, you know, we argued and we kind of kibitzed back and forth, but I think the bottom line is, here it's some kind of a hybrid solution. I even was joking before, why don't we use, you know, what the resources out there can we do? And I was doing a little research. What's the delta T needed to enable geothermal by the water? You know, and actually it's not that much. Question is, can you use the air, which is very cold, because you need to complete the Carnot cycle. And you know, there may be a solution out there that we haven't thought about. So all kinds of crazy. So we call it the wacky competitions, wild and crazy ideas. And I think that might be something we should do in this initiative and for this area, and see what comes out. What do you think? Well, no, she'll tell me to do it since I thought of it. So, but what do you think of doing something like that? Is that a good idea, bad idea? But you would need to write some kind of a white paper that describes at least a baseline of what we did this weekend, and you know, nothing that would be out of bounds in terms of other alternative solutions that they might think of. but you need to give them something to work with if we were going to do a competition.
So in other words, we'll be in touch.
And Mohammed would run it at UAA, he told me. So I'm kidding, but maybe you can have it.
Yeah, I think this is a good suggestion. I think there's an interim one too, right? To Mohammed's question is once you do the research, I'll use the data for example, upload your data, it becomes exposed to the entire world. They can have competitions that can talk about their own social issues. Other people can use that data to derive results. So it's very hard to say that your research here will affect people locally. That's a hard one. But I think once you open it up to where the data is available for anybody to look at, they can derive solutions out of it. And you don't have to pay for the data upload. They're open sourcing. I think that's very possible. I think through the competitions, we can actually organize things. So I think there's, I like the white paper idea, but I think even without it, you can get going. The problem is, I think when you do your research, you write your publication and you walk away. And then the data is wasted per se, right? So uploading it, I think, has a lot of potential.
So the other thing is that I was going to add research was, do you also write an article in the local paper about the outcome of your research? Right? Do you usually? Yeah. So when I did my PhD, right, my supervisor said, Micah, I want you to write an article no more than a page, well, maybe a page and a half, for Physics 13. We then had still grade 13 students in Ontario. And those students have to understand what you're saying. If you cannot write that article, you do not deserve your degree. That was that. So what I'm getting at is, when we write scientific papers, we often write in a language which understands other than our own community. Okay. So, well, let me give you another example. So I was a conference chair of a power and energy conference, and there was a late paper, and so I sent it to the technical committee chair, and I said, look, I'd really like to include this paper. And came back and says, why would you do that? That's physical chemistry or whatever. And we have a power and energy conference. And I said, yeah, but I said, this is the basis for the next, storage, a battery storage type or electricity storage device. He says, how do you know that? Well, what I didn't share before, because I was kind of wondering what would happen, was that group had already started a startup company, and they had done a 2-pager talking about how that outcome from the research could be used, because they were looking for money, right? So investors. So the thing is, if we would write that type of a 1 or 2-pager to go with our research, so that communities around us actually see what came out of the work, then it might actually get used. So we need to translate the work into the language of the people whom we want to understand the work and use it. I mean, I'm standing on this little podium here, and I've given this speech many times, so it's visible, it's noticeable, right?
I forgot to point out one thing. You're talking about incentives. I think once we do design competitions, we do go for sponsorships, and there are prizes. So there is some incentive potential there. And I think to Bob's point about the data being not shareable, then you get a problem, right? So those companies then have to open up, utilities, whoever, or the data has to be, what was the term you're saying? De-fingerprinting. I use anonymize or masking, right? So vendor, which later.
So we are over time. Some people have a commitment at 6:30. People would like to get home, I'm pretty sure, some of you. I would like to, first of all, give all of you a big, huge hand. Thank you so much for being here.